NM cable, commonly known as Romex, utilizes type THHN conductors. THHN stands for thermoplastic high heat resistant nylon. These conductors are rated for a temperature of 90 degrees Celsius or 194 degrees Fahrenheit. If the jacket is nylon or polyvinyl chloride, it is rated for wet locations. NC cable or metal-clad cable typically contains type TW or XHHW conductors. TW stands for thermoplastic water resistant, while XHHW stands for cross-linked high heat resistant water resistant. The temperature rating for TW conductors is 60 degrees Celsius or 140 degrees Fahrenheit. XHHW conductors are rated for 90 degrees Celsius or 194 degrees Fahrenheit. Regarding wet location ratings, TW conductors are not rated for wet locations, while XHHW conductors are. Romex or NM cable does not use type TW conductors. It uses THHN conductors, which, as mentioned, are rated for 90 degrees Celsius. The presence of the letter W in a conductor type does not automatically qualify it for wet locations. A prime example is TW, which is water resistant but not suitable for wet locations. Romex should not be installed in underground conduit due to its inability to handle the moisture and environmental conditions inherent to underground environments. The National Electrical Code, or NEC, provides guidelines and specifications for different types of conductors and their applications. It is important to consult the NEC to ensure compliance and safety in electrical installations. The NEC specifies the allowable ampacities for conductors based on their temperature ratings. For example, conductors with a 90 degrees Celsius rating can carry a higher current than conductors with a 60 degrees Celsius rating, assuming all other factors are equal. However, the termination temperature ratings of the equipment connected to the conductors must also be considered. The lowest temperature rating among the conductor, the termination, and any other connected devices will determine the maximum allowable ampacity. When selecting conductors for a specific application, consider the ambient temperature, the presence of moisture, and the type of equipment being connected. Always choose conductors that are rated for the most severe conditions that may be encountered. Using the incorrect type of conductor can lead to overheating, insulation breakdown, and potentially dangerous electrical hazards. Always consult with a qualified electrician or electrical engineer if you have any questions or concerns about selecting and installing conductors. The correct installation methods are important as well. For example, conductors installed in conduit may have different ampacity ratings than conductors installed in free air. This is due to the difference in heat dissipation. Conductors in conduit tend to run hotter than conductors in free air because the conduit restricts airflow. When installing conductors in conduit, it is important to follow the NEC guidelines for conduit fill. Conduit fill refers to the percentage of the conduit's cross-sectional area that is occupied by conductors. Overfilling a conduit can lead to overheating and damage to the conductors. The NEC specifies the maximum allowable conduit fill for different types of conduits and conductors. In addition to temperature ratings, conductors also have voltage ratings. The voltage rating of a conductor indicates the maximum voltage that the conductor can safely handle. It is important to select conductors with a voltage rating that is equal to or greater than the voltage of the circuit in which they will be used. Using conductors with an insufficient voltage rating can lead to insulation breakdown and electrical hazards. Conductors are also available in different sizes, which are typically measured in American wire gauge, or AUG. The size of a conductor determines its ampacity. Larger conductors have a higher ampacity than smaller conductors. The appropriate conductor size for a particular circuit depends on the amount of current the circuit will carry. The NEC provides tables that specify the allowable ampacities for different conductor sizes. When selecting conductors, it is important to consider the voltage drop in the circuit. Voltage drop is the decrease in voltage that occurs along the length of a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction and can also lead to overheating of the conductors. The NEC recommends limiting voltage drop to a maximum of 5%. To minimize voltage drop, use larger conductors or shorten the length of the circuit. There are different types of insulation materials used for conductors. Common insulation materials include thermoplastic high heat resistant nylon or THHN, polyvinyl chloride or PVC, and cross-linked polyethylene or XLPE. Each insulation material has its own unique properties and advantages. THHN insulation is heat resistant and abrasion resistant, making it a good choice for general purpose wiring. PVC insulation is moisture resistant and chemical resistant, making it a good choice for wet or corrosive environments. XLPE insulation has a high temperature rating and excellent electrical properties, making it a good choice for high voltage applications. Conductors can be either solid or stranded. Solid conductors consist of a single solid wire, while stranded conductors consist of multiple smaller wires twisted together. Stranded conductors are more flexible than solid conductors and are therefore easier to work with, especially in tight spaces. Solid conductors are typically less expensive than stranded conductors and are often used for residential wiring. The National Electrical Code, or NEC, is updated every 3 years. It is important to stay up to date with the latest version of the NEC to ensure that your electrical installations are safe and compliant. The NEC covers a wide range of topics related to electrical safety, including conductor sizing, overcurrent protection, grounding, and wiring method. Many jurisdictions also have their own local electrical codes that are based on the NEC. It is important to comply with both the NEC and any applicable local electrical codes. Electrical work can be dangerous if not performed properly. It is always best to hire a qualified electrician for any electrical work that you are not comfortable doing yourself. A qualified electrician has the training and experience necessary to perform electrical work safely and in accordance with the NEC. When working with electricity, always follow proper safety procedures. Always turn off the power to the circuit before working on it. Use insulated tools and wear appropriate personal protective equipment, such as safety glasses and gloves. Never work on electrical equipment in wet conditions. Be aware of the potential hazards of electricity and take steps to avoid them. The color coding of electrical conductors is standardized to help identify the different conductors in a circuit. In the United States, the standard color code for branch circuits is as follows: black for hot or live conductors, white for neutral conductors, and green or bare for grounding conductors. Other colors may be used for hot conductors in certain situations, such as 3-way or 4-way switch circuits. The color code helps electricians and other workers to quickly and easily identify the different conductors in a circuit, which reduces the risk of electrical shock and other hazards. It is important to follow the color code when wiring electrical circuits. Never use the white wire for a hot conductor. Always use the green or bare wire for the grounding conductor. The NEC specifies the allowable ampacity of conductors based on their insulation type, size, and installation method. The ampacity of a conductor is the maximum amount of current that the conductor can safely carry without overheating. It is important to select conductors with an ampacity that is sufficient for the amount of current that the circuit will carry. The NEC provides tables that list the allowable ampacities for different types of conductors. These tables take into account the insulation type, size, and installation method of the conductor. The NEC also provides starting factors that must be applied to the ampacity of conductors in certain situations. For example, if conductors are installed in a conduit with other conductors, their ampacity must be directed to account for the increased heat generated by the conductors. The directing factors are based on the number of conductors in the conduit and the ambient temperature. It is important to consult the NEC to determine the appropriate directing factors for a particular installation. Overcurrent protection devices, such as circuit breakers and fuses, are used to protect electrical circuits from overloads and short circuits. These devices are designed to interrupt the flow of current in a circuit if the current exceeds a certain level. The NEC requires that all electrical circuits be protected by overcurrent protection devices. The size of the overcurrent protection device must be matched to the ampacity of the conductors in the circuit. The overcurrent protection device should be sized to protect the conductors from overheating, but it should not be so small that it trips unnecessarily. The NEC provides guidelines for selecting the appropriate size of overcurrent protection devices. Grounding is an important safety measure that helps to protect people from electrical shock. Grounding provides a low resistance path for fault current to flow back to the source, which causes the overcurrent protection device to trip and to energize the circuit. The NEC requires that all electrical systems be grounded. Grounding is typically accomplished by connecting the metal enclosures of electrical equipment to a grounding electrode, such as a ground rod or a metal water pipe. The grounding electrode is connected to the earth, which provides a low resistance path for fault current to flow back to the source. Grounding also helps to reduce the risk of static electricity buildup, which can damage sensitive electronic equipment. Bonding is the process of connecting together all of the metal parts of an electrical system to create a continuous electrical path. Bonding helps to ensure that all of the metal parts of the system are at the same electrical potential, which reduces the risk of electrical shock. The NEC requires that all electrical systems be bonded. Bonding is typically accomplished by using bonding jumpers to connect together the metal enclosures of electrical equipment, metal conduit, and other metal parts of the system. The bonding jumpers must be sized appropriately to carry the fault current. Surge protection devices are used to protect electrical equipment from voltage surges, which are sudden increases in voltage that can damage or destroy electronic equipment. Voltage surges can be caused by lightning strikes, power outages, and other events. Surge protection devices work by diverting the excess voltage to ground, which protects the equipment from damage. The NEC recommends that surge protection devices be installed on all electrical systems, especially those that serve sensitive electronic equipment. There are different types of surge protection devices available, including whole-house surge protectors and point-of-view surge protectors. Whole-house surge protectors are installed at the main electrical panel and protect all of the equipment in the house from voltage surges. Point-of-view surge protectors are plugged into individual outlets and protect the equipment that is plugged into those outlets.